Hello, my name is Connor McGee. I am the head graphics designer of World of Warcraft, and today I will be explaining how the physics engine works along with the help from Nick and Sarah. And now for Nick.
I'm one of the creators of World of Warcraft, and I'm going to show how physics is involved in this game. For instance, vector addition is used throughout this game. For example, if a dwarf was running 15 meters north, turned, and then ran 10 meters east, the result would be 18 meters. If that same dwarf ran 20 meters in 5 seconds, then the average velocity of that dwarf would be 4 meters per second. So if the velocity of that dwarf is 4 meters per second, and if you divide that by the time, which is 5 seconds, the average acceleration of that dwarf would be 0.8 meters per second per second.
Being able to run and accelerate also help find lost frisbees. As we see in this clip, a monk begins to group his enemies and then performs a spinning crane kick, which deals with central pedal force, velocity, and acceleration. Nick will explain this further.
A monk does a spinning crane kick at 20 meters per second, and the height of his leg would be 1 meter. When you're doing this, you have to make sure to square the velocity. So 20 squared would be 400. So 400 divided by 1 is 400, obviously. And then, so the central pedal acceleration would be 400 meters per second per second.
Similar to central pedal acceleration, there is central pedal force. Central pedal force is a force that acts on a body moving in a circular path and is always directed toward the center around which the body is moving. To solve for central pedal force, you use the equation central pedal force equals the mass times the central pedal acceleration. Dwarf's leg from the example before weighed 30 kilograms and had a central pedal acceleration of 400 meters per second per second. So 30 kilograms times 400 meters per second is equivalent to 12,000 newtons of force. A major part of the physics engine is angular projectile motion, and to explain this we will be using the concept of bows and arrows within the game.
A gnome shoots a bow and arrow at a 45-degree angle with an initial velocity of 120 meters per second, and it travels for 10 seconds. To figure out how far away the target is, we would use a displacement formula. It equals initial velocity times time plus half acceleration time squared. The target is 709.5 meters away from the gnome.
Universal gravitation is a force between two objects that is practically unsensible unless the objects are extremely huge, like the size of a planet. To solve for universal gravitation, you take the mass of the first object and the mass of the second object, and you divide it by the distance between the objects, and you have the distance squared. Another key element when building the physics engine is horizontal projectile motion. When solving for horizontal projectile motion, many variables come into play. Some of these variables include the initial velocity in the x and y axis, the final velocity in the x and y axis, the acceleration in the x and y axis, and the displacement in the x. To create a simple problem for horizontal projectile motion, we could use the example of having a final velocity in the x-axis of 134 meters per second and an initial velocity in the x-axis of 134 meters per second, because the final and the initial velocity in the x-axis are always the same, and the final velocity in the y-axis as negative 130 meters per second, and the final velocity in the y is 0 meters per second. Also, the acceleration in the x-axis is 0 meters per second because there is no outside force acting upon it, and the acceleration in the y-axis is negative 9.81 meters per second because that is the gravity on Earth. Similar to horizontal projectile motion, there's another element called vertical projectile motion. Unlike horizontal projectile motion, vertical projectile motion is easier to solve. For vertical projectile motion, you need initial velocity, final velocity, acceleration in the x-axis, displacement in the x-axis, and time. An example of vertical projectile motion could be having an initial velocity of 8 meters per second and a final velocity of 3 meters per second, an acceleration of negative 9.81 meters per second, and solving for the displacement and the time. To solve for time, we use the formula final velocity minus the initial velocity divided by the acceleration. So it would be 3 seconds minus 8 seconds divided by negative 9.81 meters per second. This comes out to be negative 5 divided by negative 9.81, which is about 0.5 seconds. To solve for the displacement, we use initial velocity times time plus half of the acceleration times the time squared. When we plug everything in, we have 8 meters per second times 0.5 seconds plus 1/2 negative 9.81 meters per second times 0.5 seconds squared.